Hello, everyone. Happy Monday or Tuesday, depending on when you're reading or watching this. It's Mrs. Warner here in person. So, if it's Monday and you're watching this, I'm not in class because I'm actually at West doing some geometry stuff with my other geometry teacher friends. Uh, if it's Tuesday and you're watching this, I'm actually in your classroom. That's crazy. Okay, so first we're going to do some perimeter on the coordinate plane. Coordinate plane is a graph grid, people, in case you were wondering what that is with the x and y axes. First of all, hopefully remember how to find perimeter. Woo, the whole thing moved, folks. Did you see that? To find the perimeter, you are going to do the distance around the outside of a figure. So if you were to travel a path around the outside of a figure, for example, like this triangle, whoop, whoop, all around the outside of it. Perimeter, distance around the outside of a figure. Now, if we are on a graph grid, we can use the distance formula. And you just took a quiz on that, so you have that memorized. It's square root of x2 minus x1 squared plus the difference in y's, so y2 minus y1 squared. Now, there was a whole purpose to learning that distance formula because say someone gave you this fantastic triangle over here and they said to you, find the perimeter of this triangle utilizing the distance formula. Now, you can't just count the boxes, folks, because it's on a diagonal. So you have to actually find the length of all three sides. Now, these questions entitle a lot of showing your work. If you're someone who's doing this stuff in your head, that's crazy because no one's going to get in your head to be able to see your work. First thing you need to do is probably make a list of the coordinates for yourself. So A is at -3, 2. B is at 2, -1. And then C is at 3, 1. So I've made a list of my coordinates there. And then you just start mathing. So, for example, I'm just going to pick one of the sides to start with. I'm going to start with side AB. I'm going to use the coordinates from AB over here. I plug them in my distance formula. Remember, whenever you square anything that's negative, it's always a positive. And AB is radical 34. Leave it like that. It's super fun. Just leave it like that. I don't even think it breaks down, folks. Now, I'm going to find another side. Let's see what's next. I'm going to look for BC next. Ooh, so I use my coordinates from BC. I fill them in my formula, and I get radical 5. So BC's length is radical 5. All right. And then I'm going to do the next one, and it's AC, and AC comes out to be radical 37. All right, now, this question doesn't tell us what to round to or how to leave our answer. If you were doing radicals, none of these radicals would add together. So I'm going to just find it to the nearest tenth. You simply pull out your calculator, you plug in radical 34 plus radical 5 plus radical 37, and to the nearest tenth, that rounds to 14.1. That was super fun. Super fun! Triangle, find the perimeter. Okay, let's move on. What do we have next? Ooh, find the perimeter of this rectangle, folks. Even more exciting. Even more exciting is if you remember that in a rectangle, the opposite sides are equal to each other. So really, do I need to do this distance formula 4 times? Technically not, folks, because if you remember the fact that the rectangle has the opposite sides equal, you really just need to do the distances of like BC or AD, one of them, and times it by 2, and then AB and times, or DC and times it by 2. Start by making a list of your coordinates. Woo! I forgot D. That's crazy. Let's put it here. D is at 4, 1, folks. That's fun. Okay. And then you're going to start mathing. So I found the distances. AB's distance, I just picked AB to start with. It's 2 radical 2. Now, if AB is 2 radical 2, so is DC. They're opposite each other, and in a rectangle, they're equal to each other. If BC is 3 radical 2, then so is AD because they're opposite each other. This question doesn't say what to round it to. Since they're radical 2's, I'm going to add them all up. Remember, that stays radical 2. So technically, the perimeter of this quad is 10 radical 2. That was so fun. So fun. Okay, now let's look at the next one. Ooh, look at this shape. Not something we exactly know the shape of. However, this one is even more fun. Because if you look at this, see how these lines are vertical and horizontal? Guess what, folks? Just count the boxes. This has a length of 1, so does this. These guys down here, this has a length of 4. Right there, 3 of the sides, we have their lengths. Count the boxes, don't make more work for yourself. However, we got to go from A to E. A to E. Here's my coordinates. I write them down. I use my distance formula. I've got radical 8. Okay, folks. It doesn't tell me what to round to or what to do, but radical 8 breaks down. I think that's 2 radical 2, correct? But really, I'm going to take this 1 plus 1 plus 4. And you might be thinking, Mrs. Warner, you only did the side of AE. AE is 2 radical 2, but if you look, these guys are actually equal to each other in the picture. So there's really another 2 radical 2. I'm writing with my mouse. That's fun. Look how great I'm doing. So 4, 5, 6 plus 4 radical 2. Oh, yeah. And then my answer, if I wanted it to the nearest tenth, I got 11.7. Okay, that was fun. Now, this next one, who cares? We're going to skip it. Skip it. All right, ready? Moving on. Next page. Area on the coordinate plane. We just did perimeter, folks. Area is the amount of space inside the figure. All right? Perimeter was the distance around the outside. Okay, we're going to use 3 methods. Method 1 requires some formulas. Area of a triangle, 1/2 base times height. Hopefully you guys know that. That's been on a couple CRs already. We got our area of a triangle. Area of any 4-sided figure, whether it's a square, rectangle, parallelogram, is length times width or base times height. Okay, so parallelograms are like our squares. Maybe we should make note of that. They can be a square, they can be a rectangle, they can be a parallelogram. Well, obviously, because that's the name of it. Or they could even look like a kite, okay? We shouldn't put kite there because that's not like the template. Okay. Oh, I know. How about the rhombus? Oh, yeah. Rhombus has all 4 sides equal, but not right angles in it. These are fun. Okay, so then area of a trapezoid. 1/2 height, base 1 plus base 2. If you can't remember what a trapezoid looks like, oh, yeah, there it is. Look at that nice straight line. Trapezoid, there are 2 bases and 2 sides, which are often called the legs, and this base, not the same length as this base. Okay. Now, in order for a segment to be a height, it has to be perpendicular to its base. So in these formulas with heights, if it's not perpendicular, you can't think it's a height. Okay, so you got to double check that. And we can always use the distance formula to find lengths if we need to. Okay, here we go. What do we got first? Ooh, the area of this quad. Okay, folks, area of a quad. Now, this quad happens to be a rectangle in the picture, but we don't really totally know that. But it is. So you're going to look at our coordinates from A to B. You're going to find this guy because it's the same length as this guy. This meets at a right angle here, and then I'm going to find the distance from B to C, this guy here, okay? Rectangle is a quad, which uses length times width. So I need my coordinates so I can find the distance. I've got 2 radical 2. I need to find the distance from B to C. I got 3 radical 2. And now I'm going to do length times width or base times height. 2 radical 2, 3 radical 2 is 6 radical 4, or 6 times 2, which is 12. Now, since we're doing area, technically this would be like units squared on there. Perimeter is just basic units. It doesn't tell us inches or anything like that, so you just would do units squared. That's fine. Okay. Squared, because there's 2 dimensions to it, length and width or base and height. Okay, that is method 1, using our distance formula and our area formulas. All right, now method 2 is crazy. I love this method. Now we've got a triangle, and I need to find the area of it, but I don't know this shape is a right triangle, and it actually might not be, folks. So I need to do something called boxing it in. And in order to box it in, you make a nice rectangle around the outside. So see how I drew this rectangle around the outside of my shape? I'm going to find the area of this rectangle and then poof, look at nice right triangles up here. Label them. Here's a triangle. That's a right triangle up here. Triangle 1. I'm going to make this triangle 2 down here. Here's another right triangle. And here's right triangle 3. And what I'm going to do is, since these are right triangles, I can count the lengths of the sides. This is 1, 2, 3, 4, 5, 6 boxes. This is 1 box. This is 2. This is 1. This is 1, 2, 3, 4, 5. And this guy has a length of 1, 2, 3. Okay, we can do it. First, you're going to find the area of the box that you made. Well, the box is 6 by 3. Notice I'm showing my formula. 6 times 3 is 18 and labeled it area of the box. All this stuff's super important. You're going to get graded on it. Now, we're going to go find our triangles. Area of triangle 1 is going to be 1/2 base times height. 1/2 1 times 6. 1 times 6 is 6. Half of it is 3. Triangle 2. 1/2 1 times 2 is 1. Triangle 3, 1/2 3 times 5 is 15. Half of that is 7.5. And now I'm going to add them all together and subtract those areas of the triangle from the box, which was 18. Okay, so 18 minus the sum of the small areas of the triangles, because I've boxed it in. It's like a shaded region problem. I don't know if you ever did those maybe in 8th grade or 7th grade. 6.5 is my answer there. That was super fun. One last method, decomposing. Break the figure into an area that you know how to find the area of. So I looked at this shape and I thought, hey, I'm going to make this guy a rectangle down here. And then there's a triangle on the top. Well, if I find the area of that rectangle, oops, I should have wrote rectangle. If I find the area of the rectangle, that's 1 by 4. 1 times 4 is 4. Area of the triangle, 1/2 base times height. My base is still 4. The height has to come from a vertex and be perpendicular to the side opposite. Ooh, that's an altitude. So that's going to be 2. Half of 4 times 2 is back to 4. 4 and 4 makes the area of that figure on the grid 8. Super fun. So 3 different methods. You can decompose it into shapes you know. If it's tilted all wacky, you can box in the triangle. And if it's a rectangle or a parallelogram or a quad, you can use your distance formula to find those. Okay, folks, that's all I have to say. And I hope you have a fantastic rest of your day. Okay, how do I shut this down? That was fun.